All right. Welcome everybody to our last lecture. Can you believe that? It's May 1st and this is the last day of me teaching you new stuff. So yay, you made it to the end. Congratulations. And I know you're tired. I'm tired. The world is tired. We just want to be back to normal again. So I applaud you for just hanging in there and sticking it out. And so we'll make sure everything goes well for you for the last week of school. The test 6 is open now, so you can take it anytime between now and Monday by 11:59, not at 11:59, because you'll be in there for a minute and then it'll kick you out. So that's in there. I will get extra credit in the case studies. They're all going to be COVID-19 case studies because they've been kicking those suckers out every week now in my case study clearinghouse thing. So we'll do that, and then we'll just Monday and Wednesday we'll review for the final. We won't have class on Tuesday. And then Monday and Wednesday, we'll just take our regular times and review for the final. We'll have the final on Thursday. I've got to pick the time because we have to do it at a time. So clear your Thursday right now as much as you can, and then we'll figure out what we'll do beyond that. So anyway, just know that Thursday morning we'll have your final. You know, it's just like being in the, or maybe, anyway, I was gonna say, maybe we just do it Wednesday at 9 because then some of you have it at 10, but anyway, we'll figure it out. I'll give you plenty of time, heads up time at what time it'll be. But for right now, clear your Thursday. Okay, and so let me know if you're gonna have any serious conflicts with that in an email. Olivia says we should do it Wednesday. I think we should do it Wednesday too, but that might be what?
I don't have Wi-Fi at my house, and I'm actually going down to my in-laws' house to do my finals because I've been using my grandparents' house.
Oh, okay.
But their Wi-Fi is really slow, and
Right.
every time I take tests, it like kicks me out because it says I don't have good Wi-Fi. And
Oh, okay.
I have so many problems. But we have to leave on Wednesday. But I could figure something out if we have to take it Thursday, but if I could take it Wednesday, that would be great. But if not, I can figure something out.
Okay. Well, we'll talk, Olivia.
Okay.
Okay. I mean, and here might be what we could do with you is we could Zoom just the two of us, and you could take your final and then do it that way. So
whatever works.
Yeah.
We can
okay.
figure it out.
I'll let you know. Okay, and that was it. Okay. All right, so let's go ahead and finish this off and be done. So what I want to do right now is go back in the notes to gastrulation and figure out, how many times have I done this? I'm still going, I don't know what I'm doing. All right, so there we go. All right. So gastrulation, again, is the process where that primitive inner cell mass, so the two laminar or the bilaminar disc where you had just the blue and the green, the epiblast and the hypoblast, are going to turn into the 3 germ layers. So we call it a trilaminar disc or a trilaminar embryo. And now trilaminar disc is actually what it's called. And at that point, you then have these 3 germ layers. So germ layers, why do we call them germ layers? Doesn't have anything to do with germs, but it has everything to do with germinate. So these are the layers from which all of our body structures are going to germinate. That's why we call them germ layers. And that's why we call, cells that are the gametes are germline, because that's what's inherited, and then the next organism, the offspring, are going to grow from that zygote that came from the germline cells. So in case you hear that, that's what they're referring to. All right, so we have endoderm, mesoderm, and ectoderm. So endoderm, remember, is on the very inside. So that's going to be all the epithelial lining of digestive, respiratory, urogenital systems. We saw that. Any glands that happen to branch off of those 4 systems, I guess you can say, are going to come, well, yeah. Sorry, I'm thinking beyond. So yeah, are going to come from, because I was thinking like bulbourethral gland, seminal vesicle. Yeah, those are going to come off of there too. And Siri is transcribing everything I'm saying. All right. Okay, so yeah, that's all endoderm. Mesoderm then is going to be everything in the middle. So all our skeleton, all our muscles, kidneys, intermediate mesoderm, reproductive organs, except the, well, part of the vagina. The bottom third of the vagina is going to come from endoderm, but it's going to come from ectoderm. The rest of it's going to come from, that's attached to the uterus, is going to come from the cloaca. Well, actually, that's endoderm, so that's going to come from the cloaca. Sorry, I'm just thinking out loud. Beyond what you're going to need to know. So reproductive organs, mesoderm, because we're going to see that today in just a minute. Circulatory system, definitely your heart and all of your blood vessels, dermis of your skin, dentin of your teeth. That's all going to come from mesoderm. Yeah, serous membrane, so all of your epicardium, not epicardium, pleura, pericardium, peritoneum, all of that. Smooth muscle, so skeletal muscle, cardiac muscle, smooth muscle, all of it's going to come from mesoderm. And then ectoderm is, of course, your superficial stuff. So the epidermis of your skin, that epithelium out there, stratified squamous, nervous tissue. So remember, your complete CNS. So brain, spinal cord, peripheral nervous system as well. The nerves as they go out, because they're going to go out in the somites and go out to your tissues. Sense organs. I'm just trying to think how, oh, I don't have a soda this morning. Dang it. Yeah, we'll just lump it together. I just want to tell you everything. Enamel of teeth, yeah, lens of the eye, more than the lens of the eye, all of your eye, you guys. I know the book that we are using where I got the notes from says lens of the eye, but actually all of your eye. You have surface ectoderm, you have neural ectoderm that come together and make your eye. So all of your eye. That's a sense organ. I don't know why I broke it out like that, because I hadn't taken the class yet. Okay, so then this just shows gastrulation. Here's endoderm. So everything, that's all the glands. So we have parathyroid, thymus, thyroid, liver, pancreas, gallbladder, okay, all of that. All right, so what we want to do now, right here, is go into how do you make a male or a female. So what's happening embryonically to develop into a male or female. We're going to start out with, we're going to start at conception with you being a male or female. Okay, so you are either an XY, which would make you a male, or you would be an XX, which would make you a female. Now, beyond that, there are some non-disjunctions that can happen. So you could be an XXX, you could be a metafemale, you could be an XXY, you could be a Klinefelter's male, you could have an XO, you could be a Turner syndrome female. I had a student I didn't even know, and she said, she goes, Miss G, I have Turner syndrome. And I went, you're kidding me. Now that explains everything. Small stature, a lot of times they have mental retardation, but she was smart. She was really smart. So she didn't have that, but she only got one X chromosome. So anatomically, it made total sense to me after she told me. She goes, oh yeah, I have Turner's. I'm like, you just, okay, thanks. You just at the end of the year. Oh, by the way, of course you don't tell everybody stuff like that. But anyway, so she only got one X chromosome because non-disjunction happened in the sperm. So the two X's that her father had to give stayed in one sperm, and then it ended up with a sperm without an X chromosome in it, and she got that one. So obviously, they survive. And in fact, I saw her this morning, and but didn't progress reproductively, so she can't have children. But she's fine with that. She goes, I can always adopt. She's like, I don't care where the baby came from. I don't have to have it. She says, I just want it. So she's really cute and has a good mindset with, you know, the cards that she was dealt. All right. So my point is, we are male or female. And then how do we develop those differences? Because when we, you know, obviously you go to find out the sex of your baby, go get the ultrasound, you know, and all the gender reveal party things and all the, you know, the trend today. And but you can't just go as soon as you're found out that you're pregnant and go and have an ultrasound and see, because nothing's showing up, because males and females look identical to one another up until a certain stage of development. And so what are those structures? That's what we're going to look at now. What are the structures that are going to give rise to male or female based on what happens with sexual development? And of course, weird things can happen. And we'll get into that. So there's always problems that can happen, but you know, most of the time you're going to get XX, XY, and then develop fully into a reproductively capable male or female. All right, so in our notes here, let me show you a picture. Okay, so it's a whole lot easier then to go back to the notes, because you're like, I don't even know what you're talking about. All right, so if we take a look at here, we have yellow and we have pink in this red. So this I'm trying to say this mesonephros. Okay, so this here, and then we have our gonadal ridge, and then we have our metanephros. This is all going to come from intermediate mesoderm, and so mesoderm, and then the rest of it are going to come as branches off of this urogenital sinus, which is going to end up as the cloaca, and we're going to have two sets of ducts. We're going to have Mullerian ducts or paramesonephric ducts. Paramesonephric means it's outside of the mesonephros, right here. This not really a kidney, because the metanephros is going to be the kidney, but this is a stage of development that is going to disappear after a while. Or you have the mesonephric ducts, the Wolffian ducts, which are actually attached to the mesonephros. So paramesonephric outside of the mesonephros, and then the mesonephric ducts, which are attached to the mesonephros itself. Now, I don't like to call them that because it's so hard to remember paramesonephric, mesonephric, because they're so close. But Mullerian and Wolffian are much different. So I am absolutely going to go with these people names. I'm all right with that. So the Mullerian ducts right here, these pink ones. So remember, at 5 to 6 weeks, you have both sets of ducts. You have the pink ducts and the tan color ducts. And the pink ducts, the Mullerian ducts, are going to develop into the female duct system. Okay, so that would be uterine tubes and uterus. And then the Wolffian ducts, are the tan ones, would develop into the male ductwork. So the epididymis, the ductus deferens, seminal vesicles, that would come from the Wolffian ducts. Okay, so how do we remember then Mullerian is female and Wolffian is male? Because women are mules and men are wolves. And, you know, that's just how I remember. Yep, we're stubborn and you guys are tough and aggressive. I don't know however we want to put that, but that's how I remember. Okay, so girls are mules and boys are wolves. So you have both ductwork at 5 to 6 weeks. So how are you going to decide, well, which one should I develop? I'm not going to develop both of them. So I need to pick one of these. And so how do we pick one? Well, let's go back here. So we have mesonephric and Wolffian and Mullerian ducts and undifferentiated gonads. We have these gonadal ridges. Don't know by looking what they are, but if we looked at the cells, sure, they would have XY or XX depending on what you are. Oh, I'm going the wrong way. Okay, So now here's the difference. In the presence of testosterone produced by the testes of the male, the Wolffian ducts develop into the epididymis and the ductus deferens. The genital tubercle becomes the penis, labioscrotal swellings become the scrotum, and testes descend down into the scrotum. AMH stands for anti-Mullerian hormone, is secreted by the testes, and Mullerian ducts degenerate. So let's go back to the picture and see what's going on here. So here we are, we've got both sets. We have the potential to become a male and a female at the same time, but that's not going to happen. So what's the special ingredient that determines if we're going to be a male or female? It's the production of testosterone by the testes here, the gonadal ridge. So let's go over to 7 or 8 weeks. So right around 7 weeks of development, 6 to 7 weeks of development, these testes, if they are XY, are going to start secreting testosterone because there's a gene on the Y chromosome called the SRY gene, or the sex-related Y gene. And that is the trigger, that's the gene that codes for the production of testosterone. So as that and a lot of other stuff too, but as that testosterone starts to be secreted, then the Wolffian ducts will proceed in their development. So in the presence of testosterone secreted by the testes bearing XY chromosomes and the SRY gene on the Y chromosome, the testosterone will make the Wolffian ducts grow, and they'll also secrete AMH, anti-Mullerian hormone. So AMH will inhibit, so notice right here it says paramesonephric ducts degenerate. So it's going to inhibit the progression or the development, differentiation, whatever word you want to use, of the paramesonephric ducts. So you'll never get uterine tubes, you'll never get fimbriae, you'll never get a uterus because AMH is inhibiting that. So testosterone stimulates the Wolffian ducts, and they'll plug in. See, notice they're not plugged into the testes. So in the testes, you'll have the seminiferous tubules, and then these efferent ductules will plug into a little spot called the reedy testes that I didn't teach you, but they'll come together, and then the sperm will be able to go through the efferent ductules into the epididymis, through the ductus deferens, and then notice that the little seminal vesicle sprouts off of there. Now the prostate gland is actually going to come from the endoderm that's here. So this is a mesoderm here that will then plug into the endoderm of the urinary bladder and the urethra. And so we have the urogenital sinus becoming the urethra, and then we're going to sprout off the bulbourethral gland and the prostate gland from the endoderm that's here. Then by birth, you can see that the testes have curved around and then descended down into the scrotum. Okay, and then we'll look at the external genitalia here in just a minute. Then we have what happens if you are not a male and you do not have the SRY gene, then you don't have testosterone. So in the absence of testosterone, the Mullerian ducts, the Wolffian ducts are going to degenerate. Okay, so we have the degenerating Wolffian ducts, no testosterone. So we're just going to keep on going being a girl, because that's what our floor plan was originally, is to become a female in the absence of testosterone. So here's the uterine tube, paramesic. So the Mullerian ducts are going to become the uterine tube. Now here's what's cool is that the two uterine tubes are going to come together and fuse to form the uterus. Now we have humans have have a U-shaped uterus like this, but a lot of mammals have a more Y-shaped uterus. So there's going to be still a split down the middle like that. I'll just draw a line, boom, like this, and then the vagina down here. Okay, and so it's shaped more like a Y. So let's take guinea pigs. I used to raise guinea pigs. here's what happens with guinea pig pregnancy is that you're going to get implantation, doop, 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 along one side of the uterus and down the other side of the uterus. And there it's going to be along the abdomen of the mommy. So once those babies are moving around inside the mommy, you can see on either side of her, babies moving. You know, in us, you just see the baby moving in the middle. But in guinea pigs, you know, all mammals really, well, placental mammals, because they have that Y-shaped uterus, then, except primates, then there you can see the babies up and down the side of the mommy before she has babies. And the last mommy that I was, that I had that was pregnant was so sad. She was supposed to have her babies. You could see them in there. And then we got up the next morning and she died. She couldn't, I guess she couldn't give birth and she died. And none of the babies were born either. And I was heartbroken, absolutely heartbroken. And so and that was 20, 30 years ago. And I haven't raised a guinea pig since then because it just was too tough on me. But anyway, here you can see that mesoderm makes that first third of the uterus. And then the endoderm is going to plug in from the outside, okay, with the cloaca and the bladder and the urethra. And so those are all going to plug up in there and then give you an outlet to the outside. So here we are at birth. There's everything, and then there's that dividing line. So the bottom half, bottom 2/3 of the vagina comes from endoderm, not ectoderm. I misspoke, and because I was like, no, wait, that comes from the cloaca. So endoderm, and then the bladder and the urethra also come from endoderm too, because you get another little split between here and here. And then the rest of it's going to come from mesoderm. Okay, so let's go back.
Miss G,
yeah.
what is it that happens then when you have those cases where they are born with both things? Is it not that
because you're not going to be completely
testosterone?
You're not going to be completely both. You will
right.
be so you could have testes that didn't descend and a uterus. And that's because you didn't have testosterone or you didn't have receptors to testosterone.
Okay.
Is typically.
But then they can still check the chromosomes and figure out which one you are and then recreate it that way.
Absolutely. And you know, we failed a lot of people historically because we looked at, and you know, sometimes the fetal adrenal gland is going to make androgens. So it's going to make some testosterone. And if you have an extra sensitive, you're still a girl, but you have too many testosterone receptors and you get too sensitive to that testosterone secretion, when you're born, you may have an enlarged clitoris and they look at it and go, oh, you know, you just have a little baby penis, but you're still a boy. And then we raise you to puberty as a boy, but you're really a female, or vice versa. And
so why don't they do the chromosomal testing when they're first born to figure that out, to not have all that confusion?
I would think now that they would do that more in the case of looking at external genitalia and seeing some, you know, indiscriminate stuff. Any question, I would think they would do that today. But you know, what we've done until today, we just go, and so anyway, I don't know, because people are dumb. All right, so let's just look at these notes and then we'll go into the external genitalia and see the different developments based on presence of testosterone or the absence of it. So if testosterone is not present due to the ovaries of a female, because she's not going to have a Y chromosome and she's not going to have SRY gene, then the Mullerian ducts continue to develop into the oviducts, uterine tubes, and uterus. The Wolffian ducts degenerate. The clitoris comes from the genital tubercle, and the labioscrotal swellings become the labia majora. All right, let's look at on the outside. So here we are at 5 weeks. We don't know what you're going to be from the outside. We can't tell. All you have is this genital tubercle, and you have these urethral folds, and these labioscrotal swellings and an anus and a urethral groove. Okay, so this is, we can build a boy from this, we can build a girl from this. Okay, so let's go build a boy. So in the presence of testosterone, the genital tubercle will enlarge and become the glans penis, and the erectile tissue that's here in the genital tubercle will become the corpora cavernosa and the corpus spongiosum. and that will elongate. Not a super lot, but it'll elongate. Then these two urethral folds right here are going to come together to enclose the urethra as the penis lengthens. And so this will fold up, and it'll actually fold up from the bottom and come up to the top. And then, and so that this raphe right here, this line, is the suture, so to speak. It's the sealed up two urethral folds right here that runs along the back of the penis. Then on the outside, we have the labioscrotal swellings, which will become the scrotum. And so as they enlarge, then the testes are going to swing down into them. And then they will, you know, because they're here on the outside. And so the testes will just descend down into the scrotum. And it's really important, like I've said before, that you palpate the scrotum to make sure that the testes have descended when your baby's born, because we got to pull them down if they haven't come down yet, to make sure that they don't become sterile. Because in that too warm of a body temperature, they will become not functional anymore. Okay, so that's what's going to happen if you're a boy. If you don't have testosterone, the glans clitoris is going to still, well, the genital tubercle will become the glans clitoris, but it's going to remain tiny. There's still erectile tissue in there, but you know, not anything like what you find in the penis. Then the urethral folds are going to remain open, and those will be the labia minora. So the folds that don't have hair on them, okay, that are there in the perineum. And so the urethral opening, of course, is going to be right in there. Then the labia majora on the outside are going to be the labioscrotal swellings will become the labia majora in a female. Okay, and then that will enclose the vestibule. Well, actually, the labia minora will enclose the vestibule, and then you've got the urethral opening right there, and then you have the vaginal orifice right there, or urethral orifice, surrounded by the labia minora, and then the labia majora on the outside. So you can see that females don't deviate from this floor plan very much at all. It's the males that really deviate. Now, just one, before I go to the next picture, just one little thing I want to show you, or I want to tell you about, as this is zipping up, and that's how my professor describes it. He goes, yeah, the urethral folds just zip up from the bottom, and they do. So it just goes full, like, what's the word I want? What did I use before? They just seal together. Well, that's not the word I use. But anyway, so they just
suture.
Huh? Okay.
Suture.
Well, there was something I said before that in the other part, but anyway, so they just come together and they'll seal up, but sometimes they don't seal up all the way right here at the end, and you'll get what's known as hypospadias, where there's an opening for the urethra, and instead of coming out at the end of the penis, that the urine comes out here in the back. And so we just have to replumb it so that the tube, urethral, you know, that comes out through the end of the penis and not here in the back. And I guess one of my students last year, she goes, oh, my little boy had hypospadias. And I'm like, oh, well, there you go. So it is rather common that this doesn't zip up all the way to the top. Okay, so anyway, in case you run across that ever in your life. All right, so let's see what's happening with those testes. So here is the testis. We have this ligament. It's actually the round ligament in a female, but it becomes a gubernaculum in a male. So it pulls the testes down into the scrotum, and then it anchors them. So at the end, by full descent into the scrotum, the gubernaculum should hang on to it and keep it from retracting back up into the body. However, sometimes it doesn't, and then that can go back up into your body. I have a friend who has twin boys, and they were in middle school, I think it was, and they were wanting to play soccer, and so they went in for their preschool, like before school, not like 4-year-old. So their before school physical, and the doctor had palpated it and went, oh, okay. And so he had to go in and have that tacked down again because his one of his testes was moving back up. Okay, so there's that. All right, so does anybody have any questions then on sex development? Okay, great. All right, fetal circulation. We already did this in lab, so we can go through this really quickly. So remember that there is one umbilical vein, two umbilical arteries. Umbilical vein is going to go from the placenta back to the fetus, but it's going to carry all of the oxygenated blood and the nutrient-rich blood that just came from exchange with the placenta, and that the umbilical vein will hook into the inferior vena cava by way of the ductus venosus. Okay, so I'll show you a picture again. So umbilical vein, so the pathway of the blood then would be placenta, umbilical vein, ductus venosus, inferior vena cava. Remember, there's an opening between the left and right atria called the foramen ovale, and so that's going to shunt the blood from the right atrium to the left atrium, so we can get it, we can bypass pulmonary circulation and get it right into systemic circulation, since there's no need really to carry blood to the lungs. And then the actual major bypass is the ductus arteriosus that's going to carry the blood. So once it's left the right atrium, if it doesn't go through the foramen ovale, it's going to go down into the right ventricle, up the pulmonary trunk, but I don't want it to go to the lungs, and so it will bypass the lungs again through the ductus arteriosus that links the pulmonary trunk to the aorta. So remember, a ductus venosus goes from umbilical vein to vena cava. Ductus arteriosus goes from pulmonary artery, pulmonary trunk to aorta. So that's how I always can remember them. And then the umbilical arteries will carry the deoxygenated, waste-laden blood to the placenta from the common iliac arteries, if you want to know where those come from. So if we take a look at this picture again, let's start here at the placenta. So this one big red umbilical vein will then carry the blood through the umbilicus, okay, up here. Now we're going to get to the ductus venosus because we're underneath the liver. So normally blood, you know, venous blood goes through the digestion blood goes through the hepatic portal vein and then into the liver and then into the inferior vena cava. But that's that right there. That's the hepatic portal vein. So we're even bypassing that. We're going to go up here. Now we're going to start to go into the liver, but we're going to bypass the liver and we're going to duct right into the inferior vena cava. Blood will then come into the right atrium. We got two choices. We can go down into the right ventricle, or we can cut through to the other side through the foramen ovale over to the left side, and then go down to the left ventricle and out the aorta. But if we go right atrium, right ventricle, then we're going to go up through the pulmonary trunk, and then we're going to go from the pulmonary trunk to the aorta and then out through the body. But notice there is some blood that goes to the lungs, because you do want blood to go to the lungs. Obviously, it's living tissue, and so it needs a blood supply. Plus, we've got to keep that pulmonary circulation going, so we're going to have, you know, pulmonary arteries, capillaries, pulmonary veins, just for practice. So no exchange will be going on, but we'll still have that pulmonary circuit there that we just want to, you know, keep open so that the lungs will be ready to go when the fetus is born. Okay, so then what's the fate? So once you don't have a foramen ovale anymore, which is going to close as soon as the pressure here, when we taking our breath and we're using our lungs now, and that pulmonary blood is coming back through the pulmonary vein and into the left atrium, that's going to close the foramen ovale. It just sticks the two, because there's two sides, they just stick right together again, and then the openings plug up, and then you're good to go. And then you're not a blue baby. And then the ductus venosus is going to turn into the ligamentum venosum, and then the ductus arteriosus will turn into the ligamentum arteriosum. So there's ligamentum arteriosum is this little connection here between the pulmonary trunk and the aorta, and then here's ligamentum venosum is just this ligament. And you can see that in the cadaver, it's just connective tissue that's there. Same with this one, this ligamentum teres that used to be the umbilical vein. You can see that too in the cadaver. Okay, so there's fetal circulation. All right, so now we need to see, well, what's happening with the mommy? So before conception, she's going to have this tiny little uterus about the size of a small pear. And then 4 months, it's going to get bigger. And 7 months, it's going to get even bigger. And 9 months, you know, she doesn't have room for that. So that's why it has to bulge out, because there's just no room. Well, it's definitely not me. I remember my head resident when I lived on campus at BYU, when she got pregnant, she was super tall. She was like 6 feet, and she and her husband were both super tall. And when she was pregnant, she didn't even show for like forever, because she was so tall. She had such a long torso that she had plenty of room to put a baby. I have no torso, so my babies all stick way out in front of me when I'm pregnant. Okay, so we're gonna have a baby right now, and then we'll be done. So how are we gonna start having a baby? Okay, so this is just all. I have 3 children. I've never been in labor on my own before, and I delivered C-sections with all 3 of them. So I am quite not the authority on this, but theoretically I know how this works, but practically I don't even know, because my babies don't ever want to leave, so they just like being in there. All right, so here's what happens is that the fetal adrenal gland is going to be releasing cortisol. That cortisol is going to, this is, you know, late in your pregnancy, not right as you're going into labor, but near the end of your pregnancy. Estrogen is going to be secreted that stimulates the cells in your myometrium, so the smooth muscle layer of your uterus needs to have some oxytocin receptors, because the oxytocin, remember, is what stimulates uterine contraction. So we need to have receptors for the oxytocin when the oxytocin starts getting made, and to antagonize progesterone. So as that process is happening, then we get Braxton Hicks contractions. Not everybody gets Braxton Hicks. I had them. I don't remember them with Amy, but I remember them with Cameron and Missy. Missy, I had them a lot. And I could just feel my whole abdomen tightening up, my uterus tightening up and everything. And it would make me flush, because it was like pushing all my blood up to my face. It was really weird. My students would be all, "You're having a contraction, aren't you?" I'm like, yeah, I am. Thanks for asking. Thanks for noticing. All right. So certain cells of the fetus, different liver, whatever, I don't remember. Let's see, it's going to produce the oxytocin. Well, actually, hypothalamus has got to produce the oxytocin. But this is baby oxytocin, its own oxytocin, is going to cause the placenta to release prostaglandins. Okay, so prostaglandins are heavily involved in inflammation. And so they're going to trigger, instead of histamine this time, they're going to trigger inflammation. And then this oxytocin always is positive feedback, you guys. So once we get, even if we get baby oxytocin being produced, that's going to go into the mom's bloodstream. It's going to go up to her hypothalamus, and it's going to say, hey, look, this baby wants to be born, so let's help it get out. And so then the hypothalamus will start producing its own oxytocin. And again, we've got positive feedback going on. So mom's oxytocin goes down to the uterus. Uterus starts to contract. Those contractions go back to her hypothalamus and say, look, we really need to get the baby out of here. And so we get more oxytocin, more contractions, more oxytocin, more contractions, until finally the baby is born. And that's the way it's supposed to work. Does not work in me. Even on Pitocin, with my first child, with Cameron, I was a week late. I was probably more than a week late, because I was huge, and he was supposed to be born in December, and here it is January, and I'm still not having a baby. And so they said, okay, we're going to induce you. So I went in on his birthday, and they hooked me up at 6:30 in the morning to the Pitocin IV. And very short time later, I started having contractions. But they were super intense. There was no gradual, warming up process. It's just like kicking in and going crazy. And I'm like, holy crap, what is this? By 5:30 that night, I still hadn't dilated beyond a 3 and hadn't effaced. And so they're like, we got to get him out of there, because every time I had a contraction, his heart rate would drop. So we just went ahead and did an emergency C-section and finally got him out of there. So this is what's supposed to happen, is that you're supposed to have the dilation and effacement stage where the uterus is, I mean, the cervix is going to dilate to 10 centimeters. That's 4 inches across. And the wall is going to thin to paper thin at 100% effacement. Initial contractions can be somewhere between 15 and 30 minutes apart. The pushing of the baby's head down on the cervix is the stimulus for softening and thinning it. My kids never dropped. My son, when even after being induced for 11 hours, well, 12 by the time I was getting ready to have the baby, the doctor said his head still was not in the birth canal, that it was still up above my pelvic outlet, so above my pubic symphysis. His head was still there, right where he made the incision. He says, I've never done an easier C-section after induction because my baby didn't go anywhere. So the next stage is the expulsion stage. So full dilation to delivery, 2 or 3 minutes between the contractions. So you're fully dilated and then the baby comes out. And all of these times are all dependent on the girl and the baby and who knows what. So we can't put time lengths on them. We just put, okay, here's the major events. And then after that, then the placenta must be delivered within 30 minutes after birth. So if we take a look at this, estrogen induces the oxytocin receptors, and then pushing down on the head, the oxytocin from the baby, from the fetus and the mother's posterior pituitary stimulates uterus contract, stimulates placenta to make prostaglandins, stimulate more vigorous contractions. All of this is positive feedback. Let's get that baby out of there. And then here is delivery. So this is the optimum way to be delivered. We want to go head first because your head is the widest diameter. You can see how your shoulders kind of fold up like that. So your head is the largest thing you're going to deliver. Because you don't deliver shoulders out sideways unless you're a big giant baby and bad stuff happens. Okay, so there's those. All right, the last thing we want to look at, because we want to deliver a baby today, is the APGAR score. So the APGAR score is our assessment of the newborn. We take it at 5 minutes, or at 1 minute and 5 minutes after birth, and we assess these 5 signs. So we look at for the heart rate in the newborn, respiration, color, muscle tone, and reflexes. And it's a 0 to 2 scale. 0 means it's absent. 1 means it's there, but it's not optimum. 2 is it's optimum. And then an APGAR score of 8 to 10 is a healthy baby. So when Cameron was born, he didn't breathe and he was absolutely purple. So he had 0 for respiration. He had a 0 for color. So right there, he's got a 6 at best. And I don't know what the rest of it was. I just know that 2 weeks after he was born, I got a call from the health department and asking me how my baby was doing. And I'm like, well, he's just fine. So apparently the hospital in Utah, in St. George, reports low APGAR scores to the health department so that they can check up on the baby and the mom after the baby goes home. So I thought that was really nice. Okay, and then last in here, I just put, these are different means of birth control right here. And you can look at that. I don't really go into that because I want to have a baby. I really want to deliver this baby. So here are 2 ways of doing prenatal testing. Both of them run some risks. So this is an amniocentesis where we draw off some amniotic fluid, but we don't want to poke the baby. And then we do chorionic villi sampling where we extract part of the chorionic villi. And then what we do is produce a karyotype so that we can check, okay, so this is the old way. So it took a long time to grow those cells out and then do the karyotype on them to see, are there any chromosomal abnormalities. So I'm sure it's much easier for us today. So Nicole, this is probably why we didn't, just do that as standard procedure after a baby's born if we question, the gender of the baby. Okay, so I'm so excited about this. Okay, we're gonna have a baby. So I think I'm gonna get a new one here. All right, so here is our uterus. All right, so here's the uterus, here's the vagina, actually this is the urethral opening, but we'll pretend this is the cervix. So you can see our cervix, it's pretty thick right there at the bottom, right? It's not very thin. So how can you get a baby out of there? So first of all, we need to impregnate her, which doesn't look anything like this. All right, so here's our baby, and I gotta watch what I'm doing. I can't watch you guys. So we're gonna impregnate her. Oh, I lost my baby. Okay. All right, So now she's pregnant. All right, so here's the baby. Well, actually, here's her uterus. There's a baby in there. All right, so now we're gonna grow the baby. Oh, dang it. I just tore her uterus. I tore her vagina. Let me try that again. These balloons aren't as good as the ones we have at EA. And I used to have super good EA ones, and then they got old, and then my uterus would pop every time I tried to deliver the baby. All right. Oh! I had these on my desk the other day, just, you know, in a bag and in a box, and Mr. Burke comes in, he goes, oh, you're gonna have a baby. I'm like, I'm so happy that you knew I was gonna have a baby. Okay, so everything's intact now. All right, so now, okay, now we're waiting for the baby to descend. Okay, so I don't know if you probably can't see in here. The baby's head right here is right up against the cervix. So now what we're gonna do is start contracting the uterus. And as the uterus contracts, watch what's happening to the cervix down here. Let me get a little closer. So we're gonna contract from the top. Get that. So you can see it shortening. It doesn't really shorten, but oh, come on. It works way better with the EA one, but I'm kind of nervous because it didn't work so great. Oh, there we go. We're almost ready. All right, so the mom's having all these contractions. She's in labor for hours. Okay, we're still going good. And look at our cervix. Almost ready. I don't want to go too far. Okay, there we go. Look, we're crowning. There you can see the baby's head. So now we're going to tell them, push, mom, push, mom. Oh, that wasn't that dramatic. Sometimes the stronger the balloon, the better our delivery, and the baby comes shooting out of there. But that's what happens. That is legit delivery. So her those uterine contractions from the top are just going to keep pushing and pushing, and that's going to thin out and efface the cervix so that the baby can come out of there. All right, so there it is, friends. Woo, I got 1 more minute to spare. All right, so does anybody have any questions on anything? No.
That was super cool though.
Wasn't that neat? I did not come up with that. That was actually a woman, I think she was in Wisconsin or somewhere. She was head of the health department someplace, and she was showing, you know, I think it was part of sex ed or something like that, but showing, you know, this is what happens when you have a baby. And I was like, holy crap, I need to do that. So
no, anyway, that was cool.
Yeah. Caden says it is a boy or a girl. I don't know. You guys decide. That's what got born.
It's a pen, so it's a penis, so it's a boy.
Okay, there we go. With the little star. A little happy boy. Woo! We'll name him Caden. All right. Okay, so there is no, he says he's honored. There is no Kahoot for this. Sorry. So just remember you're going through male and female reproductive system and the growth and development notes. And then on Monday, we will meet and we will review for the final. Oh, I'm going to put the extra credit in. I'm going to put the final review note thing. And so bring that and we'll go over that. And then we'll Kahoot as well. And we'll probably Kahoot on Wednesday. So we'll go over any questions that you might have. So take a look after you take this weekend's test. pull out the study guide for the final and highlight any concepts that you really need me to go over again. Because I'm not going to do a whole semester in a review. That's, way too much stuff. So let's just pick out those things that we really need to know more stuff about. So you guys need to let me know what you want to go over. And then we'll Kahoot on Wednesday and then take our test on Thursday. All right. I am going to work on the lab practical grades and doing those things. I haven't even looked at them yet, so I'm going to look at them right now. Okay, other than that, I guess that's it. So again, thank you so much for being such a great class and having the opportunity to teach you, and I just hope great and wonderful things for you, but I'll tell you that in the final again. That's when I'll cry. So okay, have a good weekend. Bye.